Hello everyone, welcome to the online class. It's good to see you again. Uh, so today we are going to see about the next part of your timers. So I'm sure you enjoyed the last video of your timers, and today we are going to see the another part of your timers. So actually I can make this video to one class, but I want you to make understand much detail about the timers because of its applications. So there are not only the timers are used to generate the delays, it can also do many things. Okay, like pulse width modulation, signal generation, periodic interrupts, and fixed frequency generation. There are multiple applications are there. As soon as you are going to study about the higher embedded systems or real-time operating systems, you can able to know the real applications of the timers. Okay, that's why I made this video into two parts. So in the first video I have covered almost all the basics of your timer, and in this video I am going to teach you about your much detailed operation of your timers. Okay, so let's start. So you know that our 8051 microcontroller consists of two independent timers, that is timer 0 and timer 1. Both are 16-bit timers, and that 16-bit timers are divided into again two 8-bit timers. So timer 0 is divided into two 8-bit individual timers, independent timers, and timer 1 is also divided into two 8-bit timers. Okay, you know these things. Now in last video we ended up with discussing about timer. If you want to control your timers, we are using two registers, that is two SFRs, special function registers. The name of those special function registers are your TCON and TMod, and we ended up the discussing in the last video about your TCON register, right? So we'll quickly revise that topic for within 10 seconds. We'll take hardly. So TF1 and TF0, what are these two flags? Timer overflow flags. So there are two timers. For timer 0, the overflow flag is to TF0, and for timer 1, it is overflow flag is TF1. Okay, the next two bits are your TR0 and TR1. What are these two bits? In order to make your timer run, okay, you need to must and should keep these bits to 1. So if you make TR0 is equals to 1, what will happen? Timer 0 will start running. Okay, similarly, whenever if you make TR1 is equals to 1, then automatically the timer will start running. Okay, whenever if you want to stop the timer, you just write 0 to the respective bits. Okay, and the next remaining 4 bits are related to your interrupts. So what is about IE1 and IE0? Interrupt, external interrupt, type external interrupt enable flag. So whenever if you take IE0 and IE1, so this is nothing but your interrupt flags, which is external interrupts. I'm sure you know that there are two external interrupts, INT0 and INT1. For INT0, the interrupt flag is your IE0, and for interrupt 1, the is IE1. Okay, the next two bits of your interrupt is IT0 and IT1. It is nothing but external interrupt type flag. So type bits, type control bits. That means we are having two different types of interrupts. One is level trigger and edge trigger. So whenever if you keep 1 to the particular bit, it can become as a negative edge triggered interrupt, and 0 means a low level triggered interrupts. So I'm sure you know these things in the last video itself. And today we are going to see about the TMod operation and the other functionality of the timer. Okay, coming to the TMod. So the name itself indicates timer mode control. So that means there are 4 modes of operations of your timer. So that modes will be controlled by your this register. Okay, TMod register. And coming to this this register and this register, this is not bit addressable. That means if you take this register, we are having 8 bits. We cannot access each bit at a time. But here in TCON register, I can access each bit at a time. That is nothing but bit addressable register. Okay, but this is not bit addressable, it is byte addressable. That means whenever if you want to write the value or read the value, you need to write the value in the form of bytes. That is your 8 bits at a time. Okay, so let's start with the TMod register. Okay, now TMod, if you take the simple, if you read the first 4 bits, the same 4 bits are repeated in the next part of your register. Okay, so this lower 4 bits is dedicatedly given to your timer or counter 0, and this is dedicatedly given to your timer or counter 1. Why? Because there are two different timers, timer 0 and timer 1. That's why we are having two different parts of this register. Okay, now coming to the first we need to know is, whenever if you want to make this device, okay, as a timer or counter, you need to use one bit. So what is that bit called? C by T bar. Actually, that is not dot. This is actually bar. So T by C by C slash T bar. That means it is indicating whether it will act as a timer or counter. You will decide whether you want to make this device act as a counter or timer. Now you tell me what is the value I need to place if I want to act as a counter. Okay. So if I take C slash T bar, so bar indicates active low. So if I want to activate the active low, you need to make it as 0. Whenever if you make it as 0, it can act as a timer. Okay. Whenever if you are putting C by C star is equals to 1, that means it is becomes your counter. Okay. So C is equals C by C bar, this bit is equals to 1, that means it is acting as a counter. It is 0, then it becomes your timer. So there are two different bits. Why? Because there are two different timers. Understood? Now here, whenever if I tell about the counter, so how the counter will operate? So whenever if it will count the external clock pulses. So external clock pulses are given in the form of T0 and T1. You know that there is a pin diagram. In the pin diagram, I have given these names T0 and T1, which is dedicatedly given to your timer 0 and timer 1, which is external inputs. So when you are giving external clock pulses or external inputs, then it becomes your counter. Whenever if you are giving the internal frequency, internal clock pulses, that is your frequency, then it becomes timer. So whenever if you want to calculate the delay, you require frequency. That means whenever this bit is 0, that becomes your timer. That means it is taking oscillator, that is the frequency of the oscillator internally. Okay. So that is about these two bits. And coming to the next bits, M0 and M1. So I'm sure you figured out why there are two bits, because there are 4 modes of operations. So I already told you. So there is mode 0, mode 1, mode 2 and mode 3. In order to select which mode I need to operate the timer or counter, I will select these 2 bits. So it is dedicatedly for your timer 0 and this is dedicatedly for your timer 1. So you need to choose whether you want to operate timer 0 in which out of these 4 modes. You can operate in any one mode, and you can able to operate any one mode of your timer with the help of these 2 bits. That's why we are having 2 separate bits for your timer 0 and timer 1. Okay. The next important bits is your gate enable control bit. So what is a gate enable means? Whenever if you see the gate anywhere in any part of this microprocessor or any subject, gate means simply it will enable or disable. Okay, that is the need of the gate. Here what we are going to enable, what we are going to disable is, we are going to enable the controlling of the timer with the help of hardware. So I will come to this point within a short period of time. So please remember this point. Whenever if I want to control, if I want to start the timer from the hardware, I will use this bit. Okay. Whenever if you are setting this gate bit is equals to 1, that means I am able to control the timer with the help of hardware. Okay. If I keep gate bit is equals to 0, that means I am not controlling this timer with the help of hardware. Okay. To control with the help of hardware and software, we are using interrupts, external interrupts. I'm sure you know that there are 2 external interrupts are there, right? INT0 and INT1. Now we are going to use this thing. So in detail, I want to explain this gate control bit with a short example. I'm sure this is our good old micro oven example. So you know micro oven, right? So if you want to heat the food, just put your food item, close the door and set the timer, hit the start button. You can able to heat the food and get the pizza out from that micro oven. You will serve that pizza to your loved ones. You already know this. But as this is a pandemic time, now in your homes you want to cook your hot pizzas, and you want to cook some cakes, biscuits, all the bakery related stuff you want to cook. Okay. But in your home there is no micro oven. Okay. Now your mommy will think that okay, my daughter or son is a very much intelligent smart people and they can make me a micro oven. Okay, with the help of their knowledge and skills. Okay. So I'm sure you are the most intelligent and smart people, and you will try to make the one micro oven. Okay, you made the microwave oven for your mother. Okay, to cook the delicious bakery item related stuff, these kind of foods. Now whenever your mommy will put that food into your micro oven, and you need to start the timer, right? Now after designing this micro oven, okay, what you have done is you forget to keep the start button. Okay. So I'm sure you know that whenever if you hit the start button, then only the timer will run. Okay. Now just now we have discussed, if I want to make the timer to run, what is the bits I need to use? TR0 and TR1. I'm sure you remember, right? Which is in the TCON register. TCON register, there are 2 bits called timer 0 and timer 1. So if you want to use any one timer, you can use. Okay, suppose there is a timer 0 you have used in your microwave oven. Now you want to start the timer. How you will start? I will write 1 to this particular bit. Understood my point? I will write 1 to this particular bit, then the timer will start keep running. Right now you design the microwave oven, and you given to that microwave oven to your mom, and your mom start cooking in that microwave oven. Now so your mom wants to start the timer. So how you to start the timer? By programmatically you need to write the value 1 here in this TCON register. Now what you will do? You will give your laptop to your mommy, please write the program to turn on the timer. So what your mommy will think? You idiot, I want to cook your delicious items and you want to do the programming. So she will hit with your that cake pan or some pizza pan with you, in your face or on your head. So wherever you want, she will beat you, right? Now in order to avoid this thing, what you need to do? You need to make her life simpler. So that means you need to start the timer. Okay, that means you don't need to do the programming, but with the help of simple hardware I need to start the timer. Understood? There comes the rescue. To rescue you from your mother, there are 2 external interrupts available for you. Okay, now these 2 external interrupts are connected to your timer 0 and timer 1. So int 0 is connected to timer 0 and int 1 is given to your timer 1. So I'm sure up to now you have understood this much, right? Now what you need to do? You need to start the timer. How to start the timer? You don't need to do the programming. So no need to do the programming. That means I need to control the timer with the help of hardware. So there comes the part of buttons. Okay, whenever if I hit the start button, then the timer 0 will start. Whenever if I hit the start button, again timer 1 will start. That means your mommy no need to do the programming, right? Yes or no? So that's why you will connect external buttons to your timers with the help of these interrupts. What is meant by interrupt? Interrupt is a signal. Okay, the signal is given to the timer. That means timer 0 or timer 1 will start, keeps running. This is called hardware control. Okay, if you want to control the timer with the help of hardware, which bit you need to enable? Gate bit. So in the TMod register. Now I understood what is the need of gate bit. So whenever the gate bit is 1, you can control the timer with the help of hardware. So what is the hardware we have used? This is your hardware buttons. Okay, now by achieving this, that means I am controlling the timers with the help of hardware with the push buttons and interrupts, and with the help by achieving this, what we have lost? We have lost the interrupts. What is the interrupt? Interrupts will able to tell the processor I want to execute a program which is highest priority than the main program, right? Now the interrupts cannot tell the processor. Why? Because interrupts are already given to the timer. That means I will lose the interrupts whenever if I am using that hardware control in these timers, right? But there is a small point to remember. Whenever if you want to start the timer, you must and should run, you must and should use the timer run bits. That is your timer 0 and timer 1. Remember this point. Whenever if you want to start the timer, you must and should use the timer 0 and timer 1 bits in your TCON register. Okay, then why I'm using hardware? Hardware also just for layman. So no, if someone don't know the programming, still they want to start the timer, then you can hit the start button. But for the programmers, you will use the timer 0 run bits. Okay, timer 0 and timer 1 run bits, TR0 and TR1, right? So that means you must and should use the timer run bits even if you are using the hardware control. This is the point to be noted here. So how to make this timer run bits when I'm using the hardware control? Whenever you hit the start button, you write some program automatically. So that our program will able to write the 1 in this timer run bits. Okay, that's how we can able to use this timer run bits in your my timers. Okay, so I will make this point clear, much clear with this another example. Now I'm sure that you have understood the hardware control. No, when you hit the, whenever if you are keeping the start button and you design the micro oven, your mommy feels very nice, and she will cook you hot bakery items related food stuff, right? Okay, so that is the need of hardware, how to control the timer with the help of hardware, with the help of these interrupts. So that's why we need to use the gate bit. Okay, now I told you just now, I must and should use the timer run bits for to start the timer. Okay, so to make this point clear, I will make you to understand the actual what is the logic will happen. Just now we have seen the register bits, okay, in the to control the timer. So how this register bits actually practically working inside the timer? Okay, this is actually the timer logic. Okay, now this is your timer. Whenever if you want to start the timer, what you need to do? You need to write the timer run bit. Okay, where is the timer run bit? Here, there is timer run bit, right? And if you want to calculate the delay, what you need? Frequency. Where is getting the frequency? From oscillator. So oscillator is generating the clock pulse, and it is dividing the clock pulses in by 12. So why 12? Already in previous slide also I given this information. So 12 megahertz by 12, because our 12 megahertz is your oscillator frequency of your 8051 microcontroller. This is dividing by 12. So I will tell you why we are dividing the 12 later. Okay. So now we have divided this frequency by 12. That means we are getting 1 megahertz as a clock frequency. Now this clock frequency has to reach this timer. Okay. To reach this timer, there are two problems. There are two switches here. If you observe, okay, there are two switches. Now, when this switch will keep to connected to this point, when this keep will be connected to this point, okay, whenever if you want to make it as a timer. So when you want to make it as a timer, whenever if you want to make C by slit as equals to 0. You remember this point? C by T bar, okay, C slash T bar is equals to 0, then it becomes your timer. Whenever C slash T bar is equals to 1, it becomes your counter. Now if I want to make this switch to connected to this particular point, what I need to make? C by T slash is equals to 0, right? So then the switch is connected to this point. Okay, now it will comes to here. Now there is another switch. What is this another switch? This is your timer run control. So in order to make the timer run control, I need to make TR0 or TR1 is equals to 1. Which timer I want to use? You make it this 1. Okay, now I make this one. See here, C by T bar equals to 0. That is connected. The switch is switched to this point. Remember? Okay, now I want to connect this switch. That means I need to get 1 here. Okay, at this particular point I need to get 1. If I want to get the 1, I need to have both ones here for these both on the inputs, right? Now what is these 2 bits means? TR0 or T1. I told you, whenever if you want to start the timer, I must and should use this bit. That means always it should be 1. And coming to this point, there is OR gate. Okay, so for OR gate, if you want to get the output 1, that means at least any one of the output inputs is 1, right? Now what is the gate bit? I told you, whenever if you want to control the hardware with the help of timer, with the help, if you want to control the timer with the help of hardware, you must and should use the gate bit. So whenever if you write 1 to the gate bit, it will allow us to control with the help of hardware. That is your interrupts. Okay, whenever if you make this bit is equals to 0, what will happen? You should not use this one. Suppose I am not using the hardware control. Now what will be the value of the gate bit? 0. Okay, so whenever if it is 0, that means I am not using this pin, right? So irrespective of this pin, I will get the output. So whenever it is 0, the NOT gate becomes your 1, and it will gives the value 1 here, right? Whenever this is 1 and this is 1, what is the value here? 1. So whenever this is 1, what will happen to the switch? It will be connected. Okay, whenever this is connected, whatever the frequency we are getting, it will go past to your timers, right? This is your clock inputs. Now understood how these bits are, gate bits and timer control bits are, timer run bits are affecting the actual internal working of your timers. As soon we have studied these bits in your registers, okay, TMod and TCON, but you have seen the practically how it is going to work in this diagram, right? Now we will start. So now I want hardware control. So what I need to make the hardware control? I will make this bit is equals to 1. That means I must and should use this pin, right? Now we will see what is happening. So I want to make it as a timer. So that's why C by T bar is equals to 0. And always I told you we need to make this as a 1. And now the gate bit has to make is equals to 0. It has to be 0 here. Okay, whenever it is 0, it becomes your 1. So both becomes 1. It is becomes 1, and it is becomes 1, and this becomes 1. Now it is connected. Now it is connected means we got it. Now whenever if you want to make hardware control, right, you are making this bit is equals to 1. Now coming to the counter. So counter operation. See the counter operation. What is happened? C by T bar is equals to 1. So whenever the C by T bar is equals to 1, the same operation. That means I am giving the clock pulses externally from here. But for the timer, where I am giving the clock pulses? From the oscillator. But for counter, I am giving the external clock pulses. That is your T0 slash T1. Okay. The rest of the operations are same. Okay. Whenever if you want hardware control, you can use the gate bit. And for interrupt 0 or interrupt 1, with the help of hardware, you can able to connect the buttons and you can control your counter. Okay, so that is about your counter or timer operation. Okay, internally. And the next one is your timer modes. So these are the most important modes of your timer. The first mode, I am sure you know there are 4 modes. To control these 4 modes, we are having 2 mode bits, mode 0 and mode 1. Okay, now what are this first mode? mode 0. So mode 0 is your first mode. So that mode 0 is also known as 13-bit timer or counter mode. Okay, 13-bit timer or counter mode. So why the name becomes 13-bit timer or counter? Now see here. Now this is your timer mode, and this is your timer stages. And whatever we have discussed previously in this diagram, that becomes your circuit. This is your part. Before that, we have discussed this circuit, right? From that circuit, I am getting the clock pulses. Okay. Now that means it can act as a timer. It can act as a counter. Okay. How many timers are there, or how many counters are there? 2. So timer 0 and timer 1. That's why I have represented with X. So X means you can replace the X with either 0 or 1 if you want to use either timer 0 or timer 1. Okay. Now, if you take TLX, so TLX is one again timer 0, so timer lower byte and timer higher byte, and this is your timer overflow flag. Okay. Now we got the clock inputs. Now we have given the frequency to the timer. What will happen? So it will keep on counting. So it will increment the clock pulses. So how many clock pulses it will increment? Up to 2 power 5. So 2 power 5 means 32. That means 0 to 31. So after 32th clock pulse, you can able to generate one signal. Okay, that is your interrupt generated by your lower byte of your timer. Now whenever this bit is received by this higher byte, it will increment. Okay, that means every time it is overflowing, it is generating interrupt. That interrupt is given to here. Whenever this overflows, it will generate one interrupt. That is your timer overflow interrupt, right? So whenever this overflows, it becomes your timer overflow interrupt. That means the timer will stop. So for in every, if you take all the 4 modes except mode 2, all the timers will stop after overflow. Okay, remember this point. Now, why they have given so now what is nothing but this is your 8-bit this is actually 13-bit timer. Why we are 13-bit timer? We are using 8 and 5 bits here. Okay, so total 13 bits. Now 13 bits, that means we can able to get maximum count of 2 power 13. What is the 2 power 13 value? 8192. Okay, so 8192, that is your maximum count. If you want to use this device as a counter, you can able to get the maximum count up to 8192. Why? Because we are using only 8 bits here, sorry, 13 bits here. And if you want to calculate the delay, maximum delay, how to get the maximum delay? I told you, multiply the maximum count into time period. That's why you will get the maximum delay. That is your total delay we need to get. So what is the time period? I told you, we have divided the clock frequency by 12. That means I'm getting 1 megahertz. For 1 megahertz, what is the time period? 1 microsecond. So 8192 into 1 microsecond, that is your 8192 microseconds. This is your maximum delay. Okay. Now, sir, you will get a question, sir. Why we are using only 5 bits here and 8 bits here? And also there is one more small thing you need to remember is always you write the diagram in the left side of your timer. TLX should be left side of your higher byte. Okay. Why? So there is a reason for it. So if you take there is a number called 1, 2, 3, 4. Now you want to increment. Okay, so if you divide this one into 2 half bytes, this is your lower byte, this is your higher byte. Remember this point. That means your lower byte is nothing but your 34 and your higher byte is nothing but your 12. Now if you want to increment the value, where you will increment? You will increment the higher byte, or if you increment the lower byte, you will increment the lower byte. Lower byte means you are adding the plus 1 to it. So what will happen? 1, 2, 3, 4 plus 1. What will happen? 1, 2, 3, 5. Okay, if you try to add from the higher byte, what will happen? 1, 3, 3, 4. That is obviously wrong, right? If you know the mathematic basics. So if you want to increment, you need to add the 1 to the lower byte. That's why the lower byte is attached here first and the later higher byte. Okay, so after incrementing this value, it will give the value to the next one so that you can able to get the next values. Similarly, if you know the mathematic basics. Okay, so while drawing this diagram in the examination, you must and should take care of this one. So the TLX lower byte always should be the left side of your higher byte because of this reason. Okay, now why I am using this mode? So actually we can use this mode to generate the delay, that is your 8192 microseconds. And in serial communication, I'm sure you have heard about this name, serial communication, where we are sending the data bit by bit. Okay, in serial communication we are using to generate the baud rate. Okay, baud rate. So to generate the baud rate, I need to divide the frequency by 32. Okay, so there is a formula for that. So don't keep concentrate on this point actually, but I want to make sure that you understand why we are using this mode. So I will explain the same point in the upcoming classes in the serial communication modes. Okay, Now there is a serial communication. You need to divide the frequency by 32. So that's why I need to use this mode. So where we are dividing the 32 frequency. Now I am getting the frequency. What is meant by 5? 5 means 2 power 5. 2 power 5 means 32. That means for every 32 clock pulses, I am getting one clock pulse. That means every 32 bits, it is overflowing. It is generating the one pulse. Okay. That means I am technically dividing the frequency by 32. Okay. That means we are using this mode especially for the baud rate generation in the serial communication. Okay. I will explain you more in detail about this particular point whenever I'm explaining the serial communication. Okay. Coming to the next mode. It is your 16-bit timer mode. If you observe this mode and this mode, what is changed? Just change only this point. Okay. TLX becomes your 8 bits. Remember, in earlier mode, we are having only 5 bits and we are having now 8 bits. Okay. This is your 16-bit timer or counter. That means we are using 8 bits and we are using 8 bits. So total becomes 16 bits. Now, if you are getting 16-bit timer or counter, what is the maximum count I can get? 65,536, 2 power 16. What is the maximum delay I will get? Again, 65,536 microseconds, because the time period is 1 microsecond. Why? Because we have divided the frequency by 12. Okay. Now, whenever if you give this frequency, what will happen? The timer lower byte will increment. So when it will overflow, after calculating the 256 clock pulses, it will generate interrupt. And after overflowing this one, it will generate again one interrupt. After that, it will generate the overflow flag, overflow interrupt. So this is the overflow flag becomes your 1. Okay. That means this mode can act as a timer as well as counter. So the maximum delay we'll be able to get is 65,536. Okay, well, the maximum count I can get is 65,536. Okay, this is 65,536 microseconds. The maximum delay are this is 65,536 microseconds, and maximum count is 65,536. Okay, count and delay. So delay is nothing but your microseconds. This is your timer mode 1. And this timer mode 1 generates the maximum delay among all the other modes. So if you take other 3 modes, the maximum delay we will get is in mode 1. So the first choice to get the maximum if you are using any timers, if you want to use any modes of the timers, the first obviously choice you choose is mode 1. Why? Because it will generate the maximum delay. Okay. If you compare the previous, we will get only 8192 microseconds. Okay. But here we are getting 65,536 microseconds. Understood this point? Now come to the next mode is timer mode 2. That is, the name is auto reload. TL from TH. So auto reload TL from TH. So auto reload from TL and TH means I am loading the value TL from TH. This is the actual meaning of that. Okay. Now, if you look at the other 2 different modes which we have discussed, this is entirely different mode. Okay, it is generating only 8 bits timers. So that means we are using only 8-bit timers here. Now we are using 2 independent 8-bit timers. That is your lower byte and higher byte. That means either timer 0 or timer 1. Now what will happen is, suppose if I want to launch a missile for every 1 minute. Okay, for every 1 minute I want to launch a missile. So there are 100 missiles, or every 1 minute I want to launch a missile. Now how to do it? We'll use the mode 1. Will use the mode 0? No, I will use the mode 2. Why? Because of this speciality. So what I am going to do is to calculate the 1 minute. Okay, how many clock pulses I need? 60 clock pulses. Okay, that means I need to get 60 counts. So I am sure you know one formula. What is that formula? Total count to be loaded is equals to maximum count minus desired count plus 1. So in yesterday's class I told you this one. So in last video. Okay, now you want 60 clock pulses. Right? Now, what is the maximum number of clock pulses it can count here? 8-bit timer up to 255, 0 to 255. That means maximum count is 255. You minus the 60, you will get 195, right? 195. Now, what is the value? There is a 1 plus 1, okay, in the formula. So that means we need to load 196 into this timer to get this exactly 60 counts. So now what I am going to do is, I am loading 196 in the lower byte of the timer as well as higher byte of the timer. Understood this point? Why I am loading? I will tell you. So whenever as soon as is loaded, you will give the clock pulses. Whenever you are giving these clock pulses, this will keep on incrementing. Whenever if you are incrementing, after overflows, it will generate one interrupt. Okay, so automatically interrupt flag will becomes 1, and it will tell the processor I have generated the interrupt. Okay, now the same interrupt is given to this buffer. This is your tri-state buffer. What is this tri-state buffer? It will allows the data to pass through it. Whenever if you enable this one, after overflow, again the value 196 has to load it into the timer lower byte. So again it will start counting from 197, 192 up to 255. That means exactly it is counting 60. For every 60 clock pulses, it is generating the interrupts. It is generating the interrupt. That means whenever the interrupt is generated, you are launching a missile. Understood this point? That means this cycle is keep on repeating. So whenever, as soon as the timer expires here, the automatically 196 will be loaded here. Okay, as soon as the timer lower byte expires, again the 196 will be loaded. So that means every 60 clock pulses I am generating the interrupt. That means I'm technically launching missiles for every 1 minute, because I am counting 60 clock pulses. Okay, that's why the name is called auto reload. So automatically it is reloading this value. Okay, so this is the theory for all these things. So now I'm told you this is a 8-bit counter or 8-bit timers. That means I can get maximum count is 256 and the maximum delay is 256 microseconds. So 256 microseconds, the maximum delay count is 256. Okay, I hope you understood this mode. The last mode is your timer mode 3, and you need to know about this name. So two 8-bit timers using a timer 0. Okay, so look at this one. There is a peculiar thing in this diagram. So timer 0 uses timer overflow flag for the timer 0, and timer 0 higher byte uses the flag of timer 1. Okay, timer interrupt flag of timer 1. So before understanding this mode, I will tell you one with small one example. And there are two families. So beautiful families. In that there are having couples. So two beautiful families are nothing but your timer 0 and timer 1. And there are couples. So TL0 and TL1. In one family, we are having one couple, lady and one boy. Okay, gent. Okay. Now, so due to some, actually these are pairs. Okay, two couple. I am sure you know the pairs, right? So due to some misunderstanding, what they have done is they have made as a breakup. Okay. Now that means your timer 0 has divided into two actually independent timers, timer TL0 and TH0. This is your assume that is a woman and this is a lady. Okay, now what has happened now? We got three timers. See, this is TL0, this is 8-bit timer, and TH0 8-bit timer, and T1, this is your 16-bit timer. That means technically I am getting three timers here. Now somehow this woman and gent, okay, break up, and now they want to perform independently. So breakup means they will use the independent, right? So independent of freedom. Now the timer 0, the timer lower byte in the timer 0, TL0, that is of your timer 0. So TL0 can able to interrupt. Okay, to make the interrupt, it needs some interrupt flag. Where is the interrupt? How many interrupt flag are there? TF0 and TF1. Okay, so because of its independent in nature, the lady, always ladies first, right? So it will occupy the timer overflow flag of the timer 0. So this is dedicated to user for timer 0. This is dedicated to user for timer. So the timer 0 now split it into actually TL0 and TS0. So the TL0 women's first means there is occupied automatically occupied the timer overflow flag TF0. For this is gent, so there is no overflow flag this one. That's why they come to rescue. Okay, brother, I will give my timer interrupt flag to you. Now you can able to take my flag. Okay, that means whenever the timer 0 lower byte expires, the timer overflow flag will timer 0 overflow flag will be able to set to 1. Whenever the higher byte of the timer 0 expires, actually the timer overflow flag of the timer 1 will able to generate the interrupt flag. Okay, now this is the diagram. Now you understood, right? So why we have timer 0 overflow flag with the lower byte of the timer 0, and why we are having the timer 1 overflow flag for the timer 0 higher byte. Okay, and there is another thing you need to note is this timer, this is two independent timers. Okay, that means this can act as both counter and timers, this one. Okay, but this one, this entire block, okay, this will act as only counter, not timer. That's why there is a only frequency. So if you look at this point, clock pulses from input stage, that means it can give internal clock pulses, external clock pulses. Internal clock pulses means frequency, external clock pulses means counter. Okay, that means it is working as a counter or timer, the upper block. But coming to the lower block, it will act as only timer. Okay, that means we are using only frequency to give this one. That's why we are not giving external clock pulses. So why? There is a reason. Okay, so I will tell you why there is a reason. So if you take the timer, So whenever if you are giving the internal clock pulses to the timer, then it will act as a timer to this device. Now if you want to take the, if you are giving external clock pulses to this device, then it becomes counter. Now how many external clock pulses inputs are there? There is a T0 and T1. Now T0 actually is given to timer 0 and T1 is given to the timer 1. It is not changed. Okay, we cannot able to change that one. But since the timer 0 is split into TL0 and TH0, the lead is first, right? The principle. So TL0 occupied the T0. That means the external clock, whatever the clock pulses we are giving externally, that is given to the TL0. That is your lower byte of your timer 0. Okay. For the timer higher byte, okay, there is no point of giving external clock pulses. That means the timer higher byte can able to get only the clock pulses from internally, which means the timer higher byte timer 0 higher byte can act as only timer. But whereas your lower byte, it can act as a timer as well as counter. Okay, what happens to the timer 1? So the timer 1 does not have any interrupts. Okay, it does not have any interrupts to tell the processor, okay, I have done my something. So that's why the timer 1 is used for serial communication. So because of we are using the timer 1 for serial communication, we have splitted the timer 0 into TL0 and TH0, and that's why the story came into the picture. Okay, actually the timer 1 is dedicated to user for the serial communication, serial port. So that means the timer 1 is working with the serial port and it is not working with the processor. Okay, that's why there is no need of to generate the interrupt to the processor. Okay, that's why the timer 1, the interrupt is given to the timer 0 higher byte. Okay, so that is your in detail about your timer. So I hope you enjoyed this video, and I think you have learned some good concepts in your timers. So if you are having any questions, you can just type in the chat box, unmute yourself, or personally ping me in the WhatsApp.